So in this video, we're going to do the next two learning objectives. So this first one is all about slope fields. And with slope fields, we kind of just use the pattern of the slope field to figure out what the answer is going to look like. So in this one, there's a bunch of different options. They give us 4 different options. First of all, this should be -1. So f of 1 is -1. If that's on my solution, f of 1 is -1. That means 1, -1 is on my graph. And then I just follow the lines of the slope field. So as I go to the right, the lines are kind of pointing me down that direction. And as I go to the left, all the lines are kind of pointing me down that direction. All right, so for A, that's what my graph should look like. And it definitely looks like it's concave down. So A looks right, and we're looking for what's false. All right, so A is not the right answer because it is a correct statement. F of -1 is 1. All right, going to the left, it wants me to kind of go like that. Going to the right, I follow the lines, and it goes like that. And that definitely looks like it's concave up, so that's out. And then both the last ones both have to do with 0, 0. So if I had the graph at 0, 0, as I go to the left, it wants me to just kind of go up like that. Down to the right, it looks like that. So is it concave up on the interval? Well, on one side it looks like it's concave up, on the other is not. So that one actually ends up being the right answer because it's false, because there is a point of inflection. There's that change in concavity for D. So D is correct. It's a true statement, so it's not the correct answer because we're looking for what's false. So C is the right answer. All right, this is also a very common question on the AP exam. Is they give you this slope field, they give you initial conditions, so for this one it's 0, 0, and ask you which of these functions could be the answer. So if y is 0 equals 0, as I go to the left, I follow the lines, and it looks something like that. Just go to the right, they're all leading me down to this horizontal line there. All right, so that is what my graph is going to look like, and the question is, which of these looks like this graph? Well, the first thing, or the most important thing to notice, is this perfectly horizontal line here is going to be an asymptote, because as my graph gets closer there, it's going to level off and just follow those perfectly flat lines. So really I'm looking at these and see which ones has an asymptote. All right, x squared minus 2 is a polynomial, so that does not have an asymptote. Sine of x is a trig function that does not have an asymptote. And both these exponentials do. But the only difference is just kind of just something to know. For an exponential with just a negative x like that, it's going to look like this. The negative x squared, all right, x squared, the negative and positive values are the same, so it actually looks something like that. And this one just goes up in one direction, so C is going to be the right answer. That's just kind of knowing what these graphs look like when you graph them. Again, if you did know this, just plug in some points, kind of figure out what the graph is going to look like. Our next one, again, the initial condition is 0, 0. As we go to the right, you can see I'm getting these super sharp lines. It's going to send me straight upward. As I go to the left, eventually I get to this horizontal set of horizontal lines. So as I can see, just like in the previous example, there's these perfectly horizontal lines here. And then all these ones that are basically vertical lines in the middle give me more asymptotes. So again, which ones have one horizontal and one horizontal asymptote? B is the picture from the previous one. So B can already be eliminated because that definitely does not look like what we're looking at. Natural log graphs look like this. They have vertical asymptotes but not horizontal asymptotes, so the natural log graph is out. So now it's between these two. And when do the asymptotes happen for a rational? When the bottom's 0. So C is going to have an asymptote at x equals 1. On the bottom, 1 minus x squared, that has an asymptote at x equals plus and minus 1. All right, so D would have 2 asymptotes, 2 vertical asymptotes, which we only have 1, so D is out. So C has to be the right answer. And again, just looking at what the graphs look like in comparison to what your answer looks like, you find the right answer. And the last thing, you have to create your own slope field for the short answer question. All right, the slope field, for every x and y value on your graph, you just want to plug it into your slope field. So if we kind of start in the top left, we have -2, 2. We have -2, 1, -2, 0, -2, -1, -2, -2. All right, so that's going to give me those kind of 5 points on the left. And for all of those, I'm going to plug into my function. When I plug in negative 2 times 2 into here, I get negative 4, negative 2, 0, positive 2, positive 4. So these are telling me the little slopes of my tangent lines at those points. So at negative 2, 2, which is this point, I have a slope of negative 4. So negative 4 is a pretty sharp slope like that. At negative 2, 1, I have a slope of negative 2, which is a little less steep than the other one. Negative 2, 0, it's flat because it's a horizontal slope. Negative 2, negative 1, it's 2. So pretty much the opposite of negative 2, 1. And negative 2, negative 2 is positive 4, so another sharp one like that. All right, so that's the basic idea. And I'm going to write down the work and not have you watch every single step. And we'll come back and look at the final answer. And after doing all that work, you get all of this. But again, for every single one, you're just looking at the x and y value. Your differential equation says to multiply the two of them and just draw a little thing with that slope. So we just pick out a couple specific ones like negative 1, 1. So negative 1, 1 is that point. When I multiply the two, I get negative 1. So the slope of that little line is negative 1. I pick another one like 2, negative 2. 2, negative 2 is here. Multiply those two, I get negative 4. So the slope of that line is negative 4. All right, so just taking every single point, plug into your differential equation to figure out the slope of that line. Our next learning objective is all about finding solutions to using separation of variables. So remember, that's getting your x's on one side, your y's on the other. For this very first one, it's actually only one step to do that because I just need to multiply both sides by dx. Because there's no y on the right, and I just take integrals. At the integral of just dy, you can think that there's that kind of imaginary 1, into just y. On the right-hand side, it looks really complicated because there's this natural log of 2. I put 1 over the natural log of 2 is just a constant. Natural log of 2 is just a number, so that's just going to stay there. And then the antiderivative, the 1 over x part, the antiderivative of 1 over x is the natural log of x, all right, plus c. All right, so it looks really complicated, but if you just think about natural log of 2 just being a number, it just stays there. And then that's a. All right, 14, a couple more steps to do your separation of variables part, because now I have to multiply both sides by the dx and multiply both sides by 3y squared. So I'm going to get 3y squared dy equals x minus 1 dx. Once I separate my variables, now I can do integration. The antiderivative of 3y squared is y cubed. The antiderivative of x minus 1 is x squared over 2 minus x plus c. And now I want to just solve for y. So I'm going to take to get rid of the y cubed, I take the 1/3 power of both sides. I'm going to get y is equal to this. And which one of those is the answer? It looks like it's D. So D is my right answer for this one, just doing separation of variables. All right, 15 is another one. There's no y on the right, so I just have to multiply both sides by dx. And take our integrals. So we're going to get y equals, what is the antiderivative of secant squared? This looks like a really hard one, but it's just one of our derivatives we have to have memorized. If I take derivative of tangent, I get secant squared. All right, so this one's just going to be a. If you don't technically have that memorized, you can just look at the answers and just know one of these answers has to be secant squared when you take its derivative, and hopefully that kind of jogs you remember that it's tangent. All right, 16 is the short answer, but it's still the same process. In this case, I'm going to divide both sides by y to get the y to the left, multiply both sides by dx. So now that the y's are on the left, the x's on the right, I can take integrals. The antiderivative of 1 over y is the natural log of y. The antiderivative of x is going to be x squared over 2 plus c. And I want to get rid of that natural log so I can get y all by itself, so I know the answer. All right, to get rid of a natural log, you use an exponential. So I'm going to raise both sides to the e. Those are going to cancel out on the left-hand side and just give me y. On the right-hand side, I'm going to get e x squared over 2 plus c. All right, that's a fine answer. One thing you could do some simplifying and actually write it like this. which is not going to be required. So either of these answers, right, is acceptable.